Hello, my name is Andrew Colvin and I am a third-year computer engineering student at York University. Today I'm going to show you my final project for EECS 3215. Up until EECS 3215, all of our courses have been about either hardware or software. Both of these subjects are taught independently from one another. The purpose of 3215 is to combine our previous knowledge in hardware and software and use it to learn more about systems at a higher level. By combining our existing knowledge, we are able to create large functional systems consisting of multiple hardware and software components. An embedded system is made of numerous components. These include sensors, such as buttons and accelerometers, actuators, such as motors and displays, and microcontrollers, which form the brain of the system. From simple systems like traffic lights to complicated systems such as cars, which combine hundreds of individual systems, the applications are endless. Almost every device we use on a daily basis has some form of embedded system inside of it. As students who are one day going to work in the field of engineering, it is important for us to learn how to create these systems. While lab demonstrations and lectures can teach us a lot, it is best to learn by doing. This project fulfills that need. By using a microcontroller that is different from the one we used in class, we are able to augment our classroom knowledge with real-world experience. Enter my final project. I wanted to learn more about internet-connected systems, also known as the Internet of Things. My goal was to create a basic sensor network that could be expanded to a full home automation system. I chose to start with a simple temperature sensor and display. The sensor sits outside and sends its temperature reading to an internet server over Wi-Fi. The display module connects to this server and displays the temperature. Since our display is internet connected, we can expand it to include other features, including getting a weather forecast for the next 3 days. Both the display and the sensor are based off the ESP8266 microcontroller. This microcontroller is very unique because in addition to its powerful 32-bit processor, it includes a full Wi-Fi chipset. All of this comes at a cost of approximately $3, making it ideal for our sensor network. One of the interesting things about the ESP8266 is that it allows you to choose between several programming languages. In an effort to learn as much as I could about using this microcontroller, I chose to use a different language for the sensor and display module. The sensor module uses a DS18B20 digital temperature sensor. This sensor communicates with the microcontroller over the one-wire protocol. The microcontroller on the sensor module runs an embedded operating system called Node MCU. This operating system allows you to write programs in a language called Lua. Our program has two main steps. When the module first powers on, it connects to a pre-coded Wi-Fi network. Once the connection has been established, the microcontroller reads the temperature from the sensor. It then sends this value to the server using an HTTP GET request. The server stores this data where it can be sent to other modules in the network. The server is a simple program written in Node.js and running on a virtual private server from DigitalOcean. It listens for requests from the sensor and then logs the data for later use. The display module uses a small graphic OLED display to show information. For this module, I chose to use a more traditional language based on the Arduino version of C. The program for the display module is based on the work of GitHub user Daniel Eichhorn. His code provided an excellent base, allowing the display to access weather forecast information provided by Weather Underground. This code was extended to connect to the server and download real-time temperature data from the sensor module. Both modules are housed in attractive 3D printed cases designed by my brother, a first-year mechanical engineering student at York University. While this is only a basic system, it can easily be expanded to include many more sensors and actuators. For example, using a motion sensor and a Wi-Fi enabled light switch, you can turn on the lights in an area of your house when motion is detected. This event could also trigger a Wi-Fi enabled camera to be streamed to several displays throughout the house, and because the server is connected to the internet, it can even send you text message alerts. The possibilities are endless. I hope you enjoyed learning more about my project and about the EECS 3215 course at York University. Thank you.